Okay, let's look at algebra. So what does algebra means? Uh, when looking at the definition, it means a system of bringing together parts that look different. What does it mean? It means simply a way to deal with unknown quantities. So for example, if I have 2 plus 3 and I don't know what is 2 plus 3, this is unknown. My question mark is unknown. And here is another example. I am adding 2 with another unknown quantity. I am getting 5. So obviously we know that the answer is 5 minus 2 and it's 3. The answer is not important. We need to look at the method because we can use the method to solve questions that are difficult. So now when looking at the stories, in looking at the first example, 2 plus 3, I can say that I had 2 pens, or it can be anything, and I got 3 more. How many do I have now? And looking at the second example, I have 2 pens and I got some pens. Now I have 5. So sum is unknown. So we generally use x for sum that is not known. Here I can replace the second equation as 2 plus x equal to 5. So this is like a balance. If we remove 2 from both sides, the balance will still be balanced. So looking at here, I have 2 plus x equal to 5. So I want to remove 2. I'm subtracting 2 from both sides, and the x will be 3. So why do we use x? We can use a, b, c, d, anything, but why do we use x? When looking at history, it came from European countries. So in Arabic, shine means unknown. So later, the Spanish, they did not have a sound for ish, and then they changed this to ck. And then what happened is that the Greek had a symbol for ck, which is chi, and then later the Latin, they said that it looked like x. So this is how we are using x for unknown quantities for now. So looking at further examples, 2 plus 3 equal to 5 is an equation. We call this as an equation in max. And then 2 plus 3 alone is called an expression. Here we call it as numerical expression because we have only numbers here. So numerical comes from numbers. So here I have looked at what is 2 plus x, and then the result will depend upon the quantity of x, which is unknown. Here I am doing a substitution method, so I am giving different values for x. I am giving 1, 2, 3 and 4, which is in the first row, and then x plus 2, I am replacing x with 1, which is 1 plus 2 is 3, and then similarly I am replacing x with 2, which is 2 plus 2 is 4, and similarly I am doing it for 3 and 4, which gives me 5 and 6. Here I have plotted it in a graph. So my x-axis is x, which is 1, 2, 3 and 4, and my y is x plus 2. And here we can see that the value increases linearly, and we can connect it to graph. Okay, now let's look at another example. Here I have straws, and I'm going to make a square. So to make a square, I'm using 4 straws, and I'm making a perfect square. And then I'm going to do another independent square. So here to make a square I have used 4 straws, and to make 2 squares totally I have used 8 straws, and then to make 3 squares I will be obviously using 12 straws. Like, how do I generalize this? We know that for a square I'm using 4 straws, which is fixed, and the number of squares depends upon what I choose to. So if I want one square, so instead of x I can give 1, and I can say that I am going to use 4 straws. If I want to make 2 squares, 4 into 2 is 8, and if I want to make 5 squares, 4 into 5 is 20. So I will be using 20 straws. This is an example. What if the squares are connected? Here I am connecting the two squares. So how many straws I have used now? I have used 1, 2, 3, 4, 5, 6 and 7. So the equation that I will be using is 3x plus 1. So x is my number of square. So here I have used, I'm making 2 squares which is connected. And here I have used 7 straws. What if I'm making 3? Here the equation says that I'm going to use 10 of the straws. So let's see. I already have 2, and I'm connecting to make the third square. So how many straws I have been using here? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So I have generalized the equation as 3x plus 1. Here I have looked at further examples. Here x plus 2 is 5. And this is the first example that we saw. And then how do we solve this? We know that the x is 3. When looking at the example of like the taras or the balance, what do? I subtract 2 from both the sides so that I can cancel the value of 2 from the left side, and then I get the value of 3. So similarly, when I look at an example here, x minus 4 is 5. But I cannot do the same here, right? So what do I need to do? I need to add plus 4 to both the sides, and then I'm making it balanced, and then I get a value of 9. This is one method. Another method I can use this is one method. Another method I can use is to do a shortcut and take the additive inverse of what is added to x. So here what is added to is x minus 4 is added, and the additive inverse of that is plus 4, uh, which gives 9. So I have shown that the 4 goes to the other side and gives plus 4, and the value of x is 9. We have seen examples with squares with straws in the video. So when I am taking independent squares, I have 4x equal to 16. My x is the number of squares. Here it's easy. I divide 4 on both the sides, and then I'm getting 4. So similarly, when looking at connected squares, I have both multiplication, addition in the same expression. So what do? I first subtract 1 from both the sides and get 3x equal to 15, and then I divide 3 on both sides, and I'm getting x is 5.